This is SpaceTime, Series 27, Episode 3, for a broadcast on the 5th of January 2024. Coming up on SpaceTime, a new study has concluded that most small satellite galaxies orbiting the Milky Way are destroyed soon after they enter the Milky Way's galactic halo. Japan's lunar lander enters orbit around the Moon in preparation for a potential touchdown later this month, and first light for NASA's new compact infrared radiometer. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has concluded that most small satellite galaxies orbiting the Milky Way are destroyed soon after they enter the Milky Way's galactic halo. The findings, reported in the Journal of the Monthly Notices of the Royal Astronomical Society, are raising new questions about the standard cosmological model, including on the prevalence of dark matter in our near-space environment. The conclusions are based on new data from the European Space Agency's Gaia mission, which suggests that dwarf galaxies might be out of equilibrium. It's long been assumed that the dwarf galaxies around the Milky Way are ancient satellites, with some having been in orbit around our galaxy for nearly 10 billion years. And this would require them to contain huge amounts of dark matter in order to provide all the gravity needed to hold them together, protecting them from the enormous gravitational tidal forces of the far more massive Milky Way. It was also assumed that dark matter was causing large differences observed in the velocities of stars within these dwarf galaxies. Trouble is, the latest Gaia data has revealed a completely different view of dwarf galaxy properties. Astronomers were able to date the history of the Milky Way thanks to the relationship that connects the orbital energy of an object to its epoch of entry into the halo, the time a dwarf galaxy first became captured by the Milky Way's gravitational field. Objects that arrived early, when the Milky Way was less massive than it is now, have lower orbital energies than more recent arrivals. The orbital energies of most dwarf galaxies are surprisingly substantially larger than that of the Sagittarius dwarf galaxy, which entered the halo between 5 and 6 billion years ago. And this implies that most dwarf galaxies must have arrived much more recently, less than 3 billion years ago. Such recent arrivals implies that nearby dwarf galaxies must have come from outside the halo, where almost all dwarf galaxies are observed to contain huge reservoirs of neutral hydrogen gas. The gas-rich galaxies lost their gas when they collided with a hot gas in the Milky Way's galactic halo. The violence of shocks and turbulence during this process completely changes the dwarf galaxies. While the previously gas-rich dwarf galaxies were dominated by the rotation of gas and stars when they were transformed into gas-free systems, their gravity became balanced by the random motions of the remaining stars. But the thing is, dwarf galaxies lose their gas in a process so violent it puts them out of equilibrium, which means that how fast their stars move is no longer in balance with their gravitational acceleration. The combined effects of gas loss and gravitational shocks due to the dive into the galaxy nicely explains the widespread velocities of the stars within the dwarf galaxy remnant. One of the curiosities of this study is the role of dark matter, that mysterious substance which we can't see, which we don't understand, which we don't even know what it's made of, but we know it exists because we can see its impact on other galaxies, stopping them from flinging apart as they rotate. Now, the absence of any equilibrium prevents any estimation of a dynamical mass for these dwarf galaxies around the Milky Way, or for that matter, their dark matter content. Also, while in the previous scenario, dark matter protected the supposed stability of dwarf galaxies, invoking dark matter actually becomes rather awkward for objects out of balance. In fact, if the dwarf galaxy already contained lots of dark matter, it would have stabilized the initial rotating disk of stars, preventing the dwarf's transition into a galaxy with random stellar motions. The recent arrival of dwarf galaxies and their transformations in the Milky Way's galactic halo explain many of the observed properties of these objects, including why they have stars at such large distances from their cores. Their properties seem more compatible with an absence of dark matter, and that's contrary to our previous understanding of dwarf galaxies as the most dark matter-dominated of objects. And of course, that then raises the question of where are all these dark matter-dominated dwarf galaxies, which the standard cosmological model predicts to be orbiting around the Milky Way? And for that matter, how can we even infer the dark matter content of a dwarf galaxy if equilibrium can't be assumed? This is SpaceTime. Still to come, Japan's lunar lander enters orbit around the moon, and first light for NASA's new compact infrared radiometer. All that and more still to come on SpaceTime. Japan's new lunar lander has entered orbit around the moon. The Japan Aerospace Exploration Agency, JAXA, says its smart lander for investigating the moon, or SLIM spacecraft, will undertake a landing attempt on the lunar surface within the next few weeks. The mission was launched back in September last year aboard an H-2A rocket from the Tanegashima Space Center south of Tokyo. 3 previous launch attempts had to be scrubbed because of bad weather. The journey to the moon wasn't a direct flight. Instead, SMART was sent into a highly elliptical orbit around the Earth, which gradually got bigger and bigger until it encompassed the moon as well. It then began tightening its elliptical orbit until it achieved a circular orbit around the moon. Mission managers say the probe will now begin its 20-minute descent down to the lunar surface on January the 20th. This is designed to touch down within 100 meters of a specific target on the lunar surface. This will allow scientists to target a specific crater or rock formation for the landing site. Once on the ground, SLIM will deploy a small spherical probe slightly larger than a tennis ball. The probe can change its shape in order to move across the lunar surface. Now, if successful, this mission will make Japan only the 5th nation after the United States, Russia, China and India to successfully land a probe on the moon. 2 previous Japanese lunar missions have both failed. Back in 2022, Japan's Motonashi lunar probe CubeSat, which was part of NASA's Artemis 1 mission, failed after deployment. And in April last year, Japanese startup iSpace also failed when their spacecraft lost communications and crashed onto the lunar surface. This is SpaceTime. Still to come, a successful first flight for NASA's new compact infrared radiometer. And later in the science report, a new study shows a human can tell when a chicken's happy. All that and more still to come on SpaceTime. NASA's first orbital experiments using its latest infrared Earth observation instrument have proven to be highly successful. The multi-band uncooled radiometer instrument, or MURRAY, was mounted aboard Loft Orbital's YAM-5 platform, which flew into space on a technology validation mission aboard a Falcon 9 rocket a year ago. Most satellite-based infrared instruments such as MODIS, the Moderate Resolution Imaging Spectrometer, and infrared radiometer fitted aboard both NASA's Aqua and Terra spacecraft, require bulky cryogenic systems weighing over 230 kilograms in order to cool the instrument down enough to reach an operating temperature of minus 185 degrees Celsius. That's needed because otherwise the optics of the infrared system are picking up the camera itself rather than the subject they're looking at. But MURRAY is different. It operates at room temperature, and so it only weighs 5 kilograms. The key to the new technology is a novel microbolometer which detects infrared radiation without a cryogenic cooler. This greatly reduces the cost and complexity of observing the planet's surface temperature from low Earth orbit. Bolometers are good because they detect infrared radiation in the form of heat and don't require cryogenic operation. Now, microbolometers still need to be held at a constant temperature in order to maintain accuracy in space. But that temperature can be room temperature, making the whole thing far easier to maintain. Earlier, during both airborne and laboratory tests, MURRAY achieved an absolute radiometric accuracy of around 1%, which is considered world-class for any long-wave infrared radiometers of any size. And the first light orbital data is suggesting the instrument performs just as well in the rigors of space. In fact, MURRAY's initial observations suggest the instrument can measure the Earth's surface temperature with a sensitivity as low as 123 millikelvin, which is comparable to existing Landsat instruments. Murray Principal Investigator Philip Ely from Leonardo Diagnostic Retrieval Systems says the unique technology could become the foundation for future orbital science missions dedicated to observing phenomena like volcanic activity.
Its superpower would be that it's a very small sensor with the power of a much greater sensor. Murray was launched by the SpaceX Transporter 6 on Tuesday, January 3rd, 2023, as one of several hosted payloads within Loft Orbital's YAM-5 washing machine-sized satellite. Murray is a smaller version on the TIRS instrument. The TIRS is more like a telephone booth size instrument, and ours is on the order of roughly a cubic foot, 35 centimeters by 30 by 30 centimeters. So we have a much smaller system. We don't have a large cryocooler. That takes up size, weight, and power, which significantly grow the instrument. Land temperature and water temperature are very important for scientists to be able to understand water monitoring, how full lakes are, for crop monitoring and other land imaging, such as fire monitoring. There's also interest in infrared for volcanic monitoring. In order to achieve radiometric accuracy on the order of 1%, state-of-the-art for radiometers, we use three techniques. The T-comp algorithm will adjust for global changes in temperature. The telescope temperature and the focal plane temperature are changing together. In addition, we have heater controllers to control the temperature throughout the orbit. And then thirdly, we use a calibration paddle that flips in front of the telescope, and then DC restores the sensor output. We take out any radiometric error that may have crept in and that the temperature may have shifted from when we did our original calibration. Murray can't afford image motion because you're flying over the Earth from low Earth orbit at 7 kilometers a second. The imagery from the scene is moving across the focal plane. So what we came up with was a technique to backscan the focal plane in a way to match orbital velocity, the piezo stage, that moves the focal plane very small distance on the order of a millimeter. It stares at the scene, it moves ahead about a millimeter, and then snaps back and does that again and again. And so what you have is a step stair system. And then we also do what's called frame stacking, superimposing those frames in order to create an image that's looked 10 times as long. I think one of the exciting things about working an ESTO program is that you get to see the results in a pretty short time scale. But to get up into space in less than 2 years, that's really an accomplishment. That's something I'm really proud of. We came up with the idea, we found the right sort of application.
That's Murray Principal Investigator Philip Ely from Leonardo Diagnostic Retrieval Systems. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study claims that while getting enough sleep can help improve your memory, it can also impact how you develop false memories. The findings, reported in the Journal of the Royal Society, follow the testing of 488 participants on their ability to memorize a list of words and then recall them between 2 and 12 hours later. At the 12-hour mark, the authors found that those who had slept during the 12-hour wait period recalled more of the words on the list than those who hadn't slept. They say participants who slept also guessed fewer entirely incorrect words. But they guessed more words that, while incorrect, were at least related to the correct words. The researchers say this means that sleep may be influencing the very nature of your memories, not just how much you remember. Scientists have used octopus DNA to discover that the West Antarctic ice sheet likely collapsed around the last interglacial period around 120,000 years ago, when global temperatures were very similar to what they are now. The findings, reported in the journal Science, compared the genetic profiles of Turket's octopus, which are found in the Weddell, Amundsen and Ross Seas, and they found genetic connectivity dating back to the last interglacial. The authors knew that this genetic connectivity could only be possible if a complete collapse of the West Antarctic ice sheet occurred during the last interglacial, thereby opening seaways linking the present-day Weddell, Amundsen and Ross Seas and allowing the octopus to spread. A new study shows that 7 out of 10 people can correctly tell if a chicken's happy or not, simply based on their clucks. The findings, reported in the Journal of the Royal Society Open Science, are based on researchers recruiting 200 people who were then played recordings of different chicken calls, some where the chickens were expecting to get a reward, and some from other contexts. The researchers say 69% of participants correctly guessed whether the chicken was excited about getting a potential reward. and previous experiences didn't appear to change how accurate their guesses were. The authors say this provides evidence that humans may be able to innately perceive the emotions of chickens, which could help us make better choices about their welfare. Well, it seems that whether or not brainwashing is real depends entirely on your definition of brainwashing. Are you talking about the influence of advertising, pushing religious or political views, or a Manchurian candidate-like ability to implant secret commands that can be triggered by a key word at some future date? If you're attempting to influence or manipulate the views or beliefs of others through advertising, religious nirvana, or biased news stories, then the answer is yes. But if you're talking about Manchurian candidate-like programs to blindly kill on command, then the answer is a very firm no. The CIA tried that with their MK-Ultra mind control program, and it failed. To explain what it all means, we're joined by Tim Mendham from Australian Skeptics. Is brainwashing real, or is it just...
This is the question.
Yeah.
I think no. The answer seems to be the idea of the Manchurian candidate.
That's what I'm getting at. That was my next question, yeah.
Yeah, the Manchurian candidate is the book and the film where you, during the Korean War, you capture some American soldiers and you bombard them with images and sounds and you...
My friend George believes in the Manchurian candidate. He believes he could become one, but then again, he's not on any meds right now and he should be.
It's the idea that you can persuade someone to do something that they wouldn't normally do by brainwashing, right?
Yeah.
You turn their brain around. And the question is, can you do that? Unlikely. The issue with brainwashing is it's applied as a description of what happens in a cult, that people follow instructions from your cult leader because they've been brainwashed. And I think really...
Well, they're doing it because everyone else is doing it. That's why they're doing it. And they don't want to appear to be out of the group.
I think what happens is there's a particular image of brainwashing, of the manipulation, psychological manipulation through serious treatment, sound and vision and whatever. The term brainwashing, though, is widely used and it's often overused. You're coming from a religious perspective, saying that the explanation of cultish behaviour is because of brainwashing is not borne out by the evidence, but there is evidence of coercive persuasion, right? Encouragement, peer pressure, enthusiasm, perceived benefit, etc. Now, whether you call that brainwashing or whether you call that offering them a better deal than anyone else, whether you call that marketing, right, is a moot point. You might not be recreating their brain in the way you want it, but you certainly can be doing treatments, if you like, or you're dealing with people in a way that might have the same result. Classic case, the Jonestown massacre. Jim Jones ran a cult in California, blah, blah, blah. He decides to move everything down to Guyana in South America and sets up a little sort of commune down there. Jonestown named after himself, which is what leaders do. And then the father of one of the followers, and there were about 1,000 of the followers, came to Guyana to try and get her back, and someone shot him and shot someone else as well. And then the cult leader...
was a US congressman or something that was injured.
He was a US congressman, yeah. And there was a film crew or something. I think someone else got shot.
Yeah.
And Jim Jones realised, oops, we're in trouble here. And he then persuaded or told or ordered his followers to commit suicide.
Drink the Kool-Aid.
And the worst thing, only it wasn't Kool-Aid, but I mean, poor old Kool-Aid gets targeted with that. But yeah, drink the Kool-Aid, which means you're a follower, an unthinking, blind-faith follower of a particular leader. So they drank the poison, cyanide, I think it was, and they gave it to their kids as well. Some people had to just drink it, some people got injected or whatever, and 900 plus, close to 1,000 people died. And you see the vision of this Jonestown with bodies everywhere. It's horrible. And they had bucket loads or 40-gallon drum loads of this Kool-Aid treatment to suicide. Now you think, why would people suicide and why would they kill their kids? And talking little kids here, if they weren't brainwashed or coercively persuaded. How far do you have to go before people will kill themselves and kill their kids? And then you come down to a definition of a cult. The term brainwashing might be out of fashion, if you like, the concept might be out of fashion, but you're not totally rewiring someone's brain. But yeah, fair enough, maybe the term brainwashing is not a particularly good term for this sort of stuff, but it's something very like it.
Is it just that weak-minded people are going to follow a charismatic leader? I mean, it doesn't matter if it's Jim Jones or the dude with the flying saucer behind the comet or who it is.
Yeah, you wonder why. I mean, that's the $64 question, isn't it? Why do people follow someone? There are various criteria. Obviously, there are various reasons why someone would follow a cult. One is a sense of community. We can all believe the same things, so therefore I feel good. One is to escape something else, and you go into go into a cave almost, a societal cave, to hide away from an unpleasant world. One is because you're being offered something, and heaven knows what you're being offered by a cult. Most of the time, it's the cult leader who's benefiting rather than the cult followers. And whether that's weak-minded, whether that's a need, a psychological need. There are people from all walks of life, different education, people who you would think, in quotes, with a cliche, these are not weak-minded people, these are intelligent people, no defence. If you hit someone for what they need, the intelligence goes out the window. And this is just true all the time. Now, most people don't join cults, which is a good thing. Most people would have some defence against it. But once you're in a cult, they're pretty much totally committed to it. And that is increasing as they inculcate various ideas to you. Is that brainwashing? Is it particularly accurate? Doesn't matter if the same result happens. If people do go out and kill on behalf of a cult, are they brainwashed to do it or are they encouraged to do it?
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.